Hi, this is Mick Elliott of Electronics Specifier, and I'm here on the Rohde & Schwarz stand. Jitter separation is increasingly causing designers problems, and Rohde & Schwarz have heard their cries for help and introduced a new jitter analysis tool. And here to talk us through some of its capabilities and features is Dr. Ernst Fleming, Director of Oscilloscope Product Management at Rohde & Schwarz. Ernst.
Hello, nice to have this opportunity to show it to you. What you see here is a board that's generating a 16 gigabit signal, and what you see here is the jitter separation software. First of all, how do we capture the signal? We capture the signal from two lines, go in with a differential channel, and then we, in hardware, build the differential signal and run the analysis on that, which is really fast with a fast update rate. And then we run the signal jitter separation that you see here. You get the total jitter, you get the random jitter, you get the period jitter. All this is a standard analysis capability that you need to do for jitter analysis. We use a special algorithm that's an analytic approach. So typically for jitter separation, you use just the time interval error, so just the zero crossings. But we, in our acquisition, we use the complete waveform. The advantage of that is that we can run a jitter separation on a much shorter capture. So what you see here is, you notice we run that on 400 kilosample and we get the full information of it. So it's much faster and much more efficient to run this with this analytic approach. This analytic approach, in addition, delivers to the standard analysis some additional capability. So the most important topic maybe is that you can analyze how much your signal is distorted between the DUT itself and where you capture it. So when you look closer to this waveform here, you see that signal is generated in the processor, but you capture it with some distance. Do you know how much your signal is distorted by that distance? Typically you don't. But with the analytic approach, you have the capability to get information on the step response that you see here. And here you already get an information of the distortion of the signal. So this is very important, very difficult to measure in the past, but now you get it automatically with this analytic approach. Another possibility is, of course, that you can, let's say, think about how would my jitter look, how would my eye look when I improve on, for example, remove the random jitter and just look for the periodic jitter. And this is what we call synthetic eye. And when you look into that here, you see just the synthetic eye as it would be with zero random jitter. So here you clearly see, okay, if I remove the random jitter, I get a decent eye, and I just get the periodic jitter that you see here, for example. So those are some of the highlights that this new analytic approach are offering. And you see it's a complete package offering the standard jitter separation plus some additional information that's a real value to the customer.
Okay. And what oscilloscopes in the Rohde & Schwarz range is this available?
This is available for the performance, high-performance oscilloscope, so it's up to 16 gigahertz on this oscilloscope, as well as on the RTO, where you have up to 6 gigahertz bandwidth.
Dr. Ernst Fleming, thank you very much indeed.